Hey and welcome back to a new video. If you've been following this channel for a longer time, then I'm sure you did not miss our progress of developing our own full cover water block with thermal Grizzly for the RTX 5090 Astral. It took us a lot of time, money and resources to bring our first full cover water block to the market, and it was much more difficult than I originally intended or expected. And we also started with the development already more than 2 years ago, when we thought, okay, let's make some very special water blocks that are different from the competition, especially with the fact that we wanted to use just normal glass instead of acrylic for the window, which did not work out, unfortunately, for the first cooler that we launched. But we finally managed to find the tricks to make it work, because it was super difficult. And in today's video, we want to check what kind of pressure these coolers can sustain. So it's now time for us to figure out how much pressure does it take to blow up a 5090 water block, or also our new upcoming CPU block that is also with normal glass as a window inside. The Seasonic PX 2200 is currently one of the strongest PSUs available, and it comes with two native PCIe 5.1 connectors, which allows to even hook up natively to RTX 5090. That is perfect for any overclocking system or high-end workstations. I'm also currently running this PSU, and so far I'm really satisfied with its quality and performance. The cables are very flexible, there are also cable comps included, and in addition also a 90-degree ATX 24-pin adapter, which also functions as a PSU tester at the same time. The fan is semi-passive, and even at a high load it is still very quiet. Find all information about this PSU in the link in the description. Acrylic, or also called PMMA, is super common in water blocks. We also use it, for example, in the micro, but it also has its downsides, which is why I wanted to move away from this for our high-end block. That was the idea over 2 years ago, when I thought of doing or expanding our portfolio into the normal water cooling segment. Back then I did a lot of research and stuff to figure out what kind of glass do we need. How do we process this? Like, how do we cut it? That's why we ended up buying a specialized water jet cutter for this. And then also, how do you treat the edges and all of this? It's not that easy as it maybe sounds. So we went all that route, but in the end, it still did not work out for the first cooler that we wanted to launch. The thing was, we made a couple of coolers, and then one day I came to the office, there was this one just sitting on my desk, and it randomly basically exploded. I just had it in my hands, and the glass inside just cracked out of nowhere, which was surprising and also very hard to debug. Like, we didn't find out what the reason was. So we took the same cooler, we reassembled it with a new sheet of glass and even did pressure tests and everything. It did not bend, it did not break, and we tried to break it intentionally, like we put things in between to put pressure on the glass. It did not break. So it was very difficult for us to figure out why did it break in the first place, and that's why we originally decided not to ship the first cooler with a glass window inside, because the risk for us was too high, because we could not figure out what the cause for the first cracking block was. We then completely redesigned the interior to make the changes for the glass. We also changed the glass type again, and now we are confident that things will work. This is our current block design, the one that we used for the acrylic plate. So we have this big piece of aluminum. So it's exactly the same as retail, just not coated. It goes for both the copper piece, which is not nickel plated, and also the aluminum piece, which is not anodized. And you have those cutouts that are milled, and then the piece of acrylic just goes inside here, and then it's basically mounted together. So we have the big copper plate, we have the O-ring around it, and they just go together, screwed, and that's basically it. Side by side, there are some changes between the glass version and the normal, currently PMMA version. Originally, this was also intended to be a glass version, which, as I said, did not work out, and we had to do some changes to it. For example, you see a change right here with this thread being gone right here. There are more changes, but I don't want to give away too much to competition, to be honest. But this one is now the glass version with the glass window inside. These two blocks are also mechanically not compatible. So if you already own a DeltaMate 5090 Astral block, it will not be possible to exchange from the PMMA to the glass window. That simply does not work. You would probably risk the same issues that we saw when we did the first blocks. And also this video is just purely to give you some insights in what we're doing in prototype development, because this is still in prototyping phase. We are still far away from mass production. We still did not start mass production of this cooler. So if you're thinking of, ordering a 5090 Astral DeltaMate block, and you're now, okay, I will wait for the glass version, I'm not sure when or if this cooler will make it to the market. That's something I want to make clear. I just want to give you some insights what we're doing in our prototyping phase. However, this block is already in mass production and also almost fully finished. That is the DeltaMate MP II that we already showed last year at the Computex. And this is also a pressure test sample, which we want to use to evaluate the strength of the glass plate that is sitting inside. So also here, we have this pretty thick glass window that is sitting inside the block. And with this sample, we also want to find out how much can this glass window take. So we are now next to our testing setup, which was established by our testing engineer, Eric. And he has quite some experience with these kind of things from his previous job. And what we have here is just a simple bath that is filled with water and basically hand pump that is sitting behind it. We're also using water as a medium to test pressure the thing, because it's non-compressible, which means that it won't explode. If you use air, just compressed air inside, and you go up to like 5 bars or something, and you will have a crack, then it will basically explode. That is something we don't want to experience standing next to it. That's why it's also going to be submerged in water. That even though it's a non-compressible fluid, it should not explode, but with glass, you could have some small pieces of glass flying around, and inside the water that should not happen. We will start with this block, which is our current version that we're selling, the PMMA version. You can see already the hose, the connection is already attached, and we will now put it into the water bath. Right now, still with one connection open, because we first have to pump water through the block to make sure all the air is out. Now we're closing it. And just to be safe, we also put another piece of acrylic on top. We are already above 5 bars, and it still looks good. Nothing is leaking, nothing is breaking. Well, I just wanted to capture the pressure, and then it breaks. But we were at about something between 8 and 9 bars, I think. The pattern also looks absolutely interesting, the way it shattered. You can see that probably the center, like the pressure built up, and then it was bulging upwards and then cracked from the center. Unfortunately, the camera was not on the item right when it broke, but I guess we will just do it again. But it's already a very good information to see that it breaks somewhere between 8 and 9 bars. And I mean, we're testing this at 600 millibars, so the safety margin seems to be really big. It's probably super difficult to see on camera, but you can see how it was bent. But it's still in one piece. So just starting all over again. This time it looks a bit different. You can see that only this corner right here cracked. Schade, dass er jetzt nicht genau gleich gebrochen ist, aber egal, wir wechseln jetzt erstmal auf die Glasversion. Bei dem anderen Acryl war es auch ähnlich, also irgendwo um die 9 Bar, wo der gebrochen ist. Jetzt bin ich mal gespannt, wo die Glasversion dann landen wird, also wie viel sie aushält und auch wie es aussieht, wenn es bricht. The second PMMA or acrylic version also bursted at about 9 bars, so quite similar, just did not look as nice when it cracked. Now we're switching over to the glass version. Now I'm absolutely curious to see if this cracks in a completely different shape and what kind of pressure this one can take. Well, that absolutely looks different. Unfortunately, I can't show both things at the same time, but I thought it was more interesting to see this crack. But we were at about 5 bars. 5 bars is less than the PMMA version, but this is also kind of expected because the acrylic or PMMA is just much more flexible when it comes to just bending and pressure. But glass is much more brittle. So once you exceed a certain point and this starts to bend, then you will have issues. But 5 bars is still much more than what we intended for. We're still testing most of the water blocks at 600 millibars, and we're currently thinking to test these at 1 bar, but that's still far, far away from the point where it broke at 5 bars. Now the last thing to test is the CPU block, and here I'm absolutely curious because of the fact of the ratio of the thickness of the glass to the area, which is a lot different to this huge area on the GPU block. Same thing here, just get the air out first. Zehn Bar. Und da ist gebrochen. So about 10 bars and it blasted. The results are absolutely amazing for us because we know that the result is much higher than what the cooler is made for, what we anticipated for. It also means that we have a huge safety margin if something goes wrong, if a pressure builds up inside your loop for whatever reason, then we know that this cooler can take enough that it should not be an issue and not break out of nowhere. So far, we always pressure tested the normal thermal Grizzly blocks at 600 millibars, which is 0.6 bar, and that is already above what you would usually expect inside your water cooling loop. There should usually be no pressure building up. You can have some pressure that could be due to thermals, so you're assembling your loop at room temperature, maybe 20-25 degrees Celsius, and then you could have a fluid temperature between 30 and 40 degrees Celsius, so that would increase the pressure a little bit, but you would not see these kind of pressures. And even the DeltaMate stuff that we're now testing at 1 bars, this should be far away from that. And especially now that we know that they fail somewhere between 8 and 10 bars, this is so far away from what you would ever expect in a water cooling loop. I can tell you with 8 or 10 bars, a lot of other things would fail first. For example, a hard tube that is sitting in a compression fitting would not last for like 10 bars. And with that, I hope you enjoyed this video, small insights in what kind of things we're testing in development. And honestly, we just also have a lot of fun just playing around with these things. I absolutely enjoy that. And that's why I wanted to take you along. I hope you enjoyed this video. See you next time. Bye-bye.